Hello and welcome to this presentation on the laws of logarithms. This presentation builds on a previous presentation looking at the definition of a logarithm. From our previous presentation, there are two types of logarithm in general engineering and scientific use. The first one is the common logarithm, that's log to the base of 10, denoted as log with a suffix 10, or simply log, we default to 10, or simply LG. Exercise 1L has a few examples if you want to try them on your calculator of using the common log key, the LOG key. If you type on your calculator log of 19.7 and press equals, you'll get the value of 1.2945. If you type in log of 512.6 on your calculator, press equals, you'll get the log value of 2.7049. And if you type in the log of 0.0145 on your calculator, you'll get the value of minus 1.8386. Values of logs less than 1 are always negative. The second type of logarithm to be aware of is a natural logarithm to the base of the exponential e. We denote that as log to the base of e, log suffix e, or more likely on your calculators it will have ln. It looks like in, but it's ln. If you want to try an exercise here, exercise 2L, on the use of the natural logarithm key, if you type ln on your calculators of 4.25, you will get the natural logarithm 1.4469. If you type in ln of 640.7, you'll get the natural logarithm of 6.4626. And if you type the ln of 0.155, you'll get negative 1.8643. Again, finding the log of a value between 0 and 1, it will be a negative log. Okay, we're now going to look at the three laws of logarithms, and it should be said that these laws apply to logs of any base, common logarithms, natural logarithms, or logs to any other base you want to use. The first law says that if we have log of a times b, where a and b are two numbers, that can be written as log of a plus the log of b. That's law 1. So in the example shown in exercise 3L here, we've got log to the base 10 of 5 times 2, where a would be my 5 and b would be my 2. That's the same as log to the base 10 of 5, log of a, plus log to the base 10 of 2, log of b. If you work that on your calculators, you'll find that's the value of 1. So whether you type in log to the base 10 of 5 times 2, or you type in log to the base 10 of 5 added to log to the base 10 of 2, you'll get the same answer. You might want to fill in the rest of the table and try and use the first law of logarithms here. Notice in this instance here and here the natural logs are used, but the laws of logs apply to all bases. Here's a solution to exercise 3L if you want to see the breakdown in the way we apply the first law. Notice in this particular case I'm just showing two ways of saying the same thing. Log of 10 plus log of 2 is the same as log of 5 plus log of 4. We get the same answer. We're still applying the first law here. The second law states that if we have the log of a divided by b, that's equal to the log of a take away the log of b. And that's law 2. So for example, now if we have log to the base e of 10 divided by 2, we could write that as log to the base e of 10 take away log to the base e of 2. You may want to fill in the rest of the table here to practice the second law. And here are the solutions to the second law problem, exercise 4L, for your reference. The third and final law of logs we need to look at is when you're raising a number to a power. Here, if we have log of a raised to the power n, we can write that as n times the log of a. That's law 3. So for example, in exercise 5L here, we have log, that's log to the base 10 here, of 10 squared. That's of the form log a to the n, where a is the 10 and n is the 2. And we can write that on the right hand side format of 2, that's the n, multiplied by the log of a, the log of 10. That applies to natural logs as well. Down here we have log to the base e of 10 squared, and the same principle applies. That's 2 times log to the base e of 10. Again, you may want to fill in the table and practice the third law. Over here is the third law and the answers to exercise 5L if you want to check your answers with the answers on the slide here. I've included table 1 here as a reference source. Basically it has a number of bases here, 1 through to 6, all raised to various powers from 0 to 6. And you can find certain values in a table with a quick and easy glance. For example, if you wanted to find 4 raised to the power of 5, you can see straight away that's 1024. I've also included the laws of indices because we'll be using those in some of the questions we're going to analyse. Don't forget the laws of logs and the laws of indices are closely related. In all the examples we are now going to review in this presentation, we're going to practice the 3 laws of logarithms. In example 2, we're asked to write log of 60 in terms of log of 2, log of 3 and log of 5 only. So the first thing with this type of question, we think, okay, how can we break 60 down into the bases of 2, 3 and 5? Because that's all we're allowed to use here. So if I multiply 2 by 5, I get 10. If I multiply 10 by 3, I get 30. Multiply 30 by 2, I get 60. So I've broken my 60 down into the bases of 2, 5 and 3. So I could write log of 60 then as log of 2 times 5 times 3 times 2. Tidying that up, I can actually bring the two 2's together because 2 squared now is 2 times 2, and then times by my 5 times by my 3. So I've got the log of 2 squared times 5 times 3. On the next line, I'm simply writing the individual log terms. So log of 2 squared plus log of 5 plus log of 3. That's the first law applied because each of the terms in the bracket were multiplied together. 2 squared multiplied by 5 multiplied by 3. That's the first law. On the final line, I've written log of 60 is equal to 2 times the log of 2. I've applied the third law of logarithms there, plus a log of 5 plus a log of 3. So in that question, we use both the first and the third law to get to our final solution. Question 4L, we're asked to write the following expressions in terms of log 2, log 3 and log 5 only. So just using the bases of 2, 3 and 5. So part A, we're given log of 15. So first of all, let's think how we can write 15 in terms of 2, 3 and 5. Well, 5 times 3 will give us 15. So I've only used bases 3 and 5 here. So log of 15 can be written as log of 5 times 3. From the first law of logarithms, log of 15 can be written as log of 5 plus log of 3, applying my first law to the right hand side of the equation. Question 4L continued, part B, we're given log of 120. Again, I need to think about how I can write 120 in terms of the bases 2, 3 and 5. So 120 can be written as 2 times 5 is 10, times by 3 gives me 30, times by 2 gives me 60, times by 2 gives me 120. And I've only used the 2, 3 and 5 bases. Just tidying that up, 120 is equal to 2 cubed, 2 times 2 above, times by 5 times by 3. So applying the first law of logarithms here, on the left hand side log of 120 is equal to log of the 2 cubed, that's log of A if you like, plus the log of 5, log of B, plus the log of 3, log of C. I've applied the first law to the right hand side of the equation. Now applying the third law of logarithms to the right hand side, I can take the first term and multiply the log 2 by 3, that's the n log A expression, and the other log expressions remain the same. Question 4L, part C, we're given log of 225. Again, we've got to express it in terms of bases 2, 3 and 5. So 225 can be written as 25 times by 9, that gives me 225, and 25 is 5 squared, and 9 is 3 squared, so I've got my bases of 3 and 5 again. So I could write the log of 225 as a log of 5 squared, 3 squared. Applying my first law on the right hand side, that can be written now as log of 5 squared plus the log of 3 squared. Using my third law on the right hand side here, I can write the first term as 2 times the log of A, the log of 5 in this case, and plus 2 times, in this case, the log of 3 for the second term then, my sort of log of A expression. I could factorise the last expression if I wanted to here. I could write that as 2 open bracket log of 5 plus log of 3 close bracket. Question 4L continued, part D here. I'm given a log of 9,000. So how can I write 9,000 in terms of my 2, 3 and 5 bases? Well, I'm going to start by writing 9,000 is 9 times 1,000. The 9 can be 3 squared and the 1,000 could be 25 times 4 times 10. So 3 squared times by 5 squared is the 25, times by 2 squared is the 4, times by 2 times 5 is the 10. So now I've broken my problem down into the bases of 2, 3 and 5. Just tidying it up with the first law of indices, I get 3 squared multiplied by 5 cubed, the 5 squared and the 5's give me 5 cubed, and times by 2 cubed, again the 2 squared times 2 cubed. So log of 9,000 can be written as log of 3 squared times by 5 cubed times by 2 cubed. Applying my first law of logarithms to the right hand side, I can write that as log of 3 squared plus log of 5 cubed plus log of 2 cubed. So I'm applying the first law to the right hand side only there. Applying my third law of logarithms now to the right hand side, I can write the first term as 2 times the log of 3, that's my n log a expression, plus 3 times the log of 5, plus 3 times the log of 2. So I've simplified my problem now into the bases of 2, 3 and 5. Example 3 here, we're asked to write the log of 9 times the square root of 4 divided by 8 in terms of just log 2 and log 3. So on the right hand side here I've got log of 3 squared would give me 9 times by the square root of 4 is actually 2 and that's divided by 8 and I can write that as 2 cubed. Simplifying, using the second law of indices on the next line, I get 3 squared times by 2 to the minus 2, that's the second law of indices, 2 divided by 2 cubed gives me 2 to the minus 2. Applying my first law of logarithm on the next line, I get log to the 3 squared plus log 2 to the power of minus 2. Applying the third law of logarithms now on the last line, I get 2 times log of 3, that's the n log of a from the previous line, and I get take away, notice a negative here because it's a negative 2 I'm multiplying by, so negative 2 times log of 2. Just be careful of the negative sign there. Question 5L, we're asked to write the following in terms of log 2, log 3 and log 5. So we're given the natural log of 4 times by the cube root of 8 here divided by 9. We've got to write that in terms of bases 2, 3 and 5. So on the right hand side here, ln, the 4 is 2 squared, that's a base of 2, times by the cube root of, and I've put 2 cubed here because 2 cubed is 8, and it's all divided by 9. I've written that as 3 squared. On the next line, I get the ln of 2 squared times by 2. Notice the cube root and the cube have cancelled each other out to leave us with 2, and that's divided by the 3 squared. Applying my first law of indices now, on the top line, bringing the 2 squared and the 2 together, I get 2 to the 3. Don't forget the 2 to the power 1 there, so 2 plus 1 gives us 3. So 2 to the 3 over 3 squared. On the next line I can apply the second law of logarithms here. This is where the log of a divided by b is equal to log of a take away log of b. So now I'll get the ln of 2 cubed take away the ln of 3 squared. Finally I apply my third law of logarithms and I get 3 times the ln 2 take away 2 times the ln 3. So I've now broken my problem down into just bases 2 and 3. Question 6L here, we're asked to write the following in terms of log 2, log 3, log 5. So we're given log of 27 times the 6th root of 25, and that's all divided by 16. So how am I going to break this down to the bases of 2, 3 and 5? Well, 27 is 3 cubed, and that's times by the 6th root of 25, so I can write 5 squared as my 25, and the 6th root is 1 upon 6 using my fractional index notation. I'm using this notation here. And on the bottom line, 16 can be written as the base of 2. It's 2 to the power of 4. So simplifying on the top line, next row I get 3 cubed times by 5 to the 2 upon 6. I'm applying there basically the third law of indices. Got a power raised to a power, so I multiply the indices there. So 2 times 1 upon 6 is 2 upon 6, and the 2 upon 4 remains in the denominator. On the next line, I get 3 cubed times by, just cancel down the index there, 2 upon 6 is 1 upon 3, and that's all upon 2 upon 4. Now I'm going to apply my first and second law to simplify this problem. Question 6L continued here. I just repeated the previous line for convenience. We've got ln of 3 cubed times by 5 to the third divided by 2 to the power of 4. We're going to apply the first and second law of logs here. So the first law of logs says we can write the ln of 3 cubed times the 5 to the third as ln of 3 to the power of 3 plus ln 5 to the power of a third, and then we take away the ln of 2 to the power of 4. That's the second law of logarithms. Apply the third law of logarithms to the last line, I now get 3 times ln 3 plus a third times ln 5, take away 4 times ln 2. And I've simplified my problem in terms of bases 2, 3 and 5. Example 4 here. We're asked to evaluate, to work out the function log of 2 take away log of 16 plus 5 times the log of 8, all divided by 3 times the log of 4. And that's without using a calculator. So the first thing we're going to do is find what base we can use here. And if you look at the question carefully, the base of 2 will be useful here. I can write log of 16, log of 8 and log of 4 all into the base of 2. So looking at my top line, I get log of 2 take away log of 2 to the power of 4, which is a 16, plus 5 times. Instead of log of 8, I'm going to have log of 2 cubed, because 2 cubed is 8. On the bottom line, I will get 3 times the log of 2 squared. 2 squared is 4. Applying my third law of logarithms on the next line, I get log of 2, take away 4 times the log of 2, plus 3 times 5 is 15 times the log of 2, all divided by, on the bottom line, 2 times 3 is 6 times log of 2. Notice the log of 2 is in every term, and that's the key here. All the terms on the top line have a log 2 in it, so we can cancel the top log 2's with the bottom log 2. So I end up with 1 take away 4 plus 15 divided by 6. Notice the 1 in front of the log 2 is 1 times log 2. Doing the arithmetic on this, we get 12 upon 6, so the answer is 2. And you can check this on a calculator. Question 7L here, we're asked to evaluate the following: log 4 plus log 8, take away half log 2 to the 4, or divided by 5 log 4, and again without using a calculator. So again we look for the base involved here, and I think it's again a base of 2, because 4 and 8 can all be written in terms of base 2. So looking at my top line, I could have the log of 2 squared for the log of 4, plus log of 2 cubed for the log of 8, take away half log of 2 to the power of 4, that's given in the question, or divided by 5 log of 2 squared for the 5 log 4. Apply my third law of indices now, I will get on the top line 2 times log of 2 plus 3 times log of 2, take away 2 times log of 2. Notice the 4 times a half gives me the 2 there. And that's divided by, on the bottom, 2 times 5 is 10 log of 2. Again, I've got log of 2 in every term here, and all I've done on the next line is added up the top terms. So 2 plus 3, take away 2, gives me 3 log 2 over 10 log 2. The log 2's cancel top and bottom. I get 3 upon 10, or 0.3. So question 8L here, we're asked to evaluate again the expression 2 times ln 25, take away ln 125 plus a half times ln 625, and that's all divided by ln 5 to the 4, again without using a calculator. Looking at the numbers here, I think the base of 5 is going to be useful here, because 25 is 5 squared, 125 is 5 cubed, and 625 is 5 to the 4. So using that knowledge, I can write the top line as 2 times ln 5 squared, take away ln 5 cubed, plus a half ln 5 to the 4. On the bottom I've got ln 5 to the 4. Using the third law of logarithms now, I can write this as 2 times 2 is 4, ln 5, take away 3 times ln 5, and here 2 times ln 5. Notice the half times the 4 gives me the 2, so it's plus 2 ln 5. All divided by, on the bottom, 4 times ln 5. Again, adding the top up, I can get 3 ln 5 on the top over 4 ln 5 on the bottom. ln 5 top and bottom, it cancels. I get 3 upon 4, or 0.75. Example 5 here, we're asked to evaluate log of 2x plus 9 plus log of x minus 4 equals to log of x squared plus x without using a calculator. So on the first line here, I basically have log of a plus log of b on the left hand side of the equation. So I'm going to apply the first law of logarithms and I bring those two brackets together. So I have log of a times b from the first law, so log of a 2x plus 9 times by the b x minus 4. The right hand side remains the same. I'm now going to take anti-logs of both sides of the equation. I've got a log of a bracket on the left hand side, a log of a bracket on the right hand side. So take anti-logs of both sides, the log terms disappear and I'm left with an algebraic equation. So 2x plus 9 times x minus 4 is equal to x squared plus x. So I've not got to try and find x now. The next line I'm going to expand the brackets, and I'll let you do this as binomial expansion, so be careful. You get 2x squared minus 8x plus 9x minus 36. I'll let you do the expansion there. It's equal to x squared plus x. On the next line I'm collating the like terms, so I'm bringing my minus 8x and plus 9x together to give me plus 1x. So I get 2x squared plus x minus 36 equals to the x squared plus x. On the next line I'm going to subtract x squared from both sides, so I get 1x squared on the left hand side plus x minus 36 is equal to x on the right hand side. So I've taken 1x squared from the left hand side and 1x squared from the right hand side. Then I'm going to subtract x from both sides, so I get x squared minus 36 equal to 0. So I've taken 1x from the left hand side and 1x from the right hand side. And finally I'm going to add 36 to both sides of the equation, so x squared is equal to 36. Square rooting both sides of the equation, finally I get x is equal to plus or minus 6. Don't forget, when you take a square root there are always two answers, plus and minus, so plus and minus 6 this time. Example 6 here. Again, we've asked to evaluate an expression. Now what you've got to notice here is that the left hand side actually contains two brackets that are the same. In the previous example the brackets were different, they had different terms in the brackets, but these are the same, so we can slightly simplify the solution here. So we've got to solve the 6 log 5x minus 3, take away 4 log 5x minus 3 equals to log 25x squared minus 81, again without using a calculator. So what we can do on the left hand side here is actually bring the terms together. Because we've got 6 times the log of 5x minus 3 and we're taking away 4 times the log of 5x minus 3, they are effectively like terms. So I can simplify the left hand side simply by adding them up. So 6 take away 4 gives me 2 times by the log of 5x minus 3. So I've simplified the left hand side in this case because the brackets are identical. The right hand side remains as log of 25x squared minus 81. Apply my third law of logarithms now to the left hand side. I bring the 2 from the front of the log to the back of the log as an index. So 2 log 5x minus 3 can be written using the third law as log of 5x minus 3 all squared. The right hand side remains the same. And again, because I've got logs of both sides of the equation, I can take anti-logs of the left, anti-logs of the right. So I end up with 5x minus 3 all squared is equal to 25x squared minus 81. Again, be careful of expanding brackets. We've got the binomial brackets here. So 5x minus 3 all squared means 5x minus 3 times by 5x minus 3. When you expand the brackets, you get 25x squared minus 15x plus 9. The right hand side remains the same. And then subtracting 25x squared from both sides and simplifying, I get minus 30x, which is the minus 15x minus 15x, minus 30x plus 9 is equal to minus 81. I've taken 25x squared from the left hand side and 25x squared from the right hand side to get that line. Now subtracting 9 from both sides of the equation, I will get minus 30x on the left hand side is equal to minus 90 on the right hand side. Rearranging the equation for x is equal to minus 90 divided by minus 30. I end up with x is equal to 3 in this case. Question 9L is very similar to the previous example. We've got to evaluate 3 times the log to the base of v of x minus 1, take away log of x minus 1 equals to log of 2 minus 2x. Notice they're all natural logarithms here. The first term, log to the base c, that's an ln function. Another way of writing the ln function is using log to the base of a. What we can notice about the left hand side again is the brackets are the same here. We've got an x minus 1 in both brackets. So basically I can take the last bracket, the 1 ln, x minus 1 from the 3 ln x minus 1 to give me 2 ln x minus 1. So I simplified the left hand side because I noticed the brackets are the same in this case. We then apply the third law of indices to the left hand side of the equation. Question 9 now continued here. Because we've got logs on both sides of the equation, we can take anti-logs of both sides of the equation to leave us with x minus 1 all squared now, the 2 minus 2x. Again, you've got to expand the x minus 1 all squared, gives you x squared minus 2x plus 1. I'll let you check that. Is equal to 2 minus 2x. And then on the next line, I've basically added 2x to both sides to get myself as x squared plus 1 is equal to 2. On the next line, I've taken 1 from both sides to give me x squared is equal to 1. And finally, x is equal to the square root of 1. And again, don't forget, take a square root, you get plus or minus 1 in this case. Question 10L here, we're asked to evaluate log of x minus 1 plus log of x plus 1 is equal to 2 times the log of x plus 2. Notice this time on the left hand side the brackets are different. We've got an x minus 1 in the first bracket and an x plus 1 in the second bracket. So I'm going to apply the first law of logarithms to the left hand side of the equation and the third law of logarithms to the right hand side of the equation here. On the left hand side I basically have log of a plus log of b, so I can write that as log of a times b, so in this case it's x minus 1 times by x plus 1. And on the right hand side I have 2 times the log of x plus 2, so I can write that as log of x plus 2 to the power 2. So I've gone from n log a to log a to the n on the right hand side. Simplifying on the next line, I've multiplied my brackets together to get log of x squared minus 1. I'll let you check that out. And on the right hand side I keep my log of x plus 2 all squared. Question 10L continued here. Because I've got logs on both sides of the equation, I've got log of a bracket on the left hand side, log of a bracket on the right hand side, I can take anti-logs of both sides. So I get x squared minus 1 is equal to x plus 2 all squared. Don't forget the x plus 2 all squared is x plus 2 times x plus 2, so expand your binomial bracket on the right hand side. You get x squared plus 4x plus 4, and on the left hand side that's equal to x squared minus 1. If I take x squared from both sides in this particular case, I get minus 1 is equal to 4x plus 4, and if I take away 4 from both sides, I will get 4x is equal to minus 5. Dividing both sides by 4, x is equal to minus 5 divided by 4, or 1 1/4. I would encourage you to have a go at some problems here, problems 4L, problems 5L, problems 6L, based on our previous examples and questions, and the answers are shown in the brackets on the right hand side here for your reference. Further problems here, problem 7L, problem 8L, problem 9L, problem 10L. I would encourage you again to have a go at these questions and the answers again in the brackets. The bibliography has been stated for your reference. I hope this has been of use to you. Thank you for viewing.